afternoon, honorable person, ladies and gentlemen. Let me introduce myself. I'm Khin from University of Computer Studies, Yangon. Today, I will do as a chair for the session 6 ICT related applications. There are two presentations in our session. Let me invite Ms. Myat Aye Aye Aung from University of Computer Studies, Yangon for the presentation.
Good morning, everybody. I'm Myat Aye Aye Aung. I'm from University of Computer Studies, Yangon. Today, I would like to talk about our proposed system. The title is end-to-end speaker-speech diarization with self-attention for conversation. This is my outline. I had divided my presentation into 6 parts. I will take 15 minutes for my presentation. If you have any question, I will answer at the end of my presentation. Let's now move on to the next slide. Firstly, I would like to talk about the background of the proposed system. Speaker diarization is a task-to-level audio or video recording with classes correspond to speaker identity, or in short, a task to identify who spoke when. There are 4 main components of speaker diarization system are speech segmentation, and then embedded feature extraction, and then clustering and resegmentation. This system can be useful for transcribing meeting, classroom speech, or medical interaction. And it also helps AI and human understand who is saying what throughout the conversation. The main problem will be solved by speaker diarization is to determine the number of people involved in a meeting or either in the meeting, broadcast news, or telephone conversation. And moreover, the speaker diarization solves the problem solving or indices and retrieval-based systems such as multimedia, indices, and speaker, indices and retrieval, etc. And it is also to support low-resource languages. That is an important pre-processing step for many speech applications. Now, turn to the next slide. I would like to talk about the target of the system. Speaker diarization has been mainly developed based on the clustering of speaker embedding. Clustering-based approach has problems such as not optimized to minimize diarization error directly and cannot handle speaker overlap correctly. So, end-to-end diarization in which a directly outboard speaker diarization result given a multi-talker recording were recently proposed. In this result, enhance end-to-end diarization by using set attention block instead of by LSTM block. In contrast to by LSTM, which is conditioned only on a previous and next hidden state. Self-attention is directly conditioned on all the other frame, making it more suitable for dealing with the speaker diarization problem. To achieve good performance and proposed method to be significantly better than the conventional by LSTM-based method. Speaker diarization is useful because it makes to increase transcript reliability and better understand what the conversation is about. Now, move on to the next slide. I would like to talk about the proposed method of the system. Typical speaker diarization systems are based on the clustering of speaker embedding. For instance, I beta, D beta, and H beta are commonly used in speaker diarization tasks. I beta means a new low dimensional speaker and channel dependent bit, which is conditioned only on the simple factor analysis. And then D beta is the average activation from the less hidden layer of deep neural network. It is unlike I beta. The I beta framework is the Gaussian distribution. And then H betas are extracted embedded features beta from deep neural network, which provide speaker-specific representation and improve speaker recognition when large amount of training data are used. So this is about the speaker embedding of features beta. And then these embedding or short segments are partitioned into speaker cluster by using clustering algorithms such as Gaussian mixture model, agglomerate hierarchical clustering, Minshew clustering, K-means clustering, etc. This clustering method have shown themselves to be as effective on various data sets. However, the clustering-based method have a number of problems. Firstly, they cannot be optimized to minimize diarization error directly because the clustering procedure is a type of unsupervised learning method. And secondly, they have trouble handling speaker overlap since The clustering algorithm implicitly assumes 1 speaker per second, and then furthermore, they had trouble adapting their speaker embedding model to real audio recording with speaker overlaps because the speaker embedding model has to be optimized with single speaker non-overlapping segment. So this problem hindered the speaker diarization application from working on real audio recording that usually contain overlapping segments. To solve the problem, this research has proposed self-identity end-to-end diarization, different from most of the other methods. The proposed method that does not rely on clustering, and instead, a self-attention-based network directly output the joint speed activity of a speaker for each time, given an input of a multi-speaker audio recording. This method can naturally handle speaker overlap during the training and inference time by exploring a multi-level classification framework. Now, turn to the next slide. I would like to talk about the impacts of the proposed system. The proposed system can avoid greedy sequential clustering in case of ultra-long sequence. A self-attention-based network directly output the joint speed activity of a speaker for each time frame, given an input of a multi-speaker audio recording. This system can provide minimal diarization error and achieve good speaker diarization performance for language conversation. And this can help extract important point or action item from the conversation entirely who said that, and can identify how many speakers were on the audio. This system is able to supply any kinds of Myanmar language meeting with colleges. The speaker diarization will let an audio recording be turned into meaningful notes right after the meeting, and this can help automatic speech recognition performance in multi-speaker conversation scenario in meetings and home environment, and able to suppose that is an important process for a wide variety of Myanmar language applications, such as information retrieval from broadcast news, meetings and telephone conversation, speaker indexing and retrieval, etc. Now, turn to the next slide. I would like to talk about the outcome of the system. There are several benefits of making good speaker diarization systems, such as improving existing speech recognition system and making transcript more meaningful and searchable, and then assisting hearing impaired people with identifying different speakers on conference call, and speaker diarization has certain application in many important scenarios, such as understanding medical conversation, multimedia information retrieval, video captioning, speaker indexing and retrieval, speech recognition with speaker identification, and diarizing meetings and lecture. So this is about that many important areas of speaker diarization system. And then these results of data sets are real-time speed, such as interview, panel discussion, and talk show data to support existing speech recognition system, especially spontaneous speech recognition in low resources. The outputs of this system and technology to benefit for any language conversation and will collaborate with new partners and colleges. Now move on to the next slide. As a conclusion, speaker diarization is an advanced topic in speech processing. It's not the problem who spoke when or who spoke when. It is highly relevant with many other techniques, such as voice activity detection, speaker recognition, automatic speech recognition, speech separation, static and deep learning. There are also challenges arising in the speaker diarization area, such as number of speakers, speech activity detection, and amount of overlap speech. So, end-to-end diarization is a neural network for speaker diarization, in which a neural network directly outputs speaker diarization result given a multi-speaker recording. The end-to-end methods can explicitly handle speaker overlap during trainings and inference times. It fits multi-speaker recording with corresponding speaker segment level. The model can be adapted to real conversation. So it could be believed that if the end-to-end method is used in this research, the experimental result will be good and can supply as a pre-processing step for various speech processing applications. Thank you for your attention.
Thank you for the presentation. This is a time for question and answer.
Thank you for your presentation. Very interesting work. I just want to confirm my understanding. So the input to this system will be waveform. Input to the system is the waveform. Wave.
That's
It the sound wave going in.
waveform,
Okay,
yes.
all right. Output will be label and word and speaker.
Speaker label.
Speaker label, but
Yes.
word no.
What? Yes.
Word yes. Okay, so it like you solve the problem of who speak and when they speak, right?
Yes.
So the when part, how do you do a segment? The who part is coming from the label, right? But the when part, how do you segment that? Because segment now is based on the input.
Yes. The segmentation, there are two types of segmentation, pixel segmentation and non-pixel segmentation. Pixel segmentation will be difficult because in the segments for speaker, the input audio has many speakers. So pixel segmentation difficult for one speaker. So times maybe the force. Maybe defined by yourself. Yes. And non-pixel segmentation will be used speaker change detection. Speaker change detection methods.
Okay.
This will be needs Bayesian hidden Markov model. Yes.
Right. But you use transformer, so the length sequence length is fixed.
Yes.
Yeah. And do you handle multi-speaker at the same time?
Yes.
You did.
Yes.
Thank you very much. Yeah, really nice work.
Any more questions?
Thank you very much for your questions. I have just one question. Yes. Have you considered the case when speakers are speaking in the situation where there is some background noise? For example, many people speak when we have music as a background, something like that.
Currently, we are use of less noise. Real-time conversation.
Okay, I see. So that means you consider the signal in the clean speed signal, right?
Yes.
Okay, thank you.
We have 2 minutes. If you have questions, please.
Yeah, thanks for the presentation. As you move from clustering, which doesn't require label, to self-attention, supervised learning, right? You would need some labels, right? In your case, do you know how many hours of recording do you need to make this work? Do you have the data or not? Yeah.
Sorry, one more time.
Oh, okay. So how many hours of recording labeled data do you think you need to make the system work? And whether you already have the data sets?
Currently, we are collecting data with our internship student. Yes. Then already data set. Yes.
Right. How many hours?
Currently, we have 11 hours. Yes.
Okay. Thank you.
Yes. Any more questions? Yeah. Thank you for the presentation. Okay, let's move to the next presenter from Singapore and Indonesia. The title of the session is Building Natural Language Processing Resources for ASEAN Languages as a Region.
Good afternoon, everyone. I'm Wei-Chi from AI Singapore, and I'll be presenting our project SEACoreNLP, which is about building NLP resources for ASEAN languages together as a region. So without further ado, let me move into the background of the project. So as a national AI program, we work very closely with the industry to solve some of the problems with AI. And one of the signals that we get consistently from the industry is actually the fact that we need NLP capabilities for Southeast Asian languages. And for example, we see requests for things like Vietnamese chatbot or Indonesian information extraction. But when we try to solve these problems, we find that there's actually not a lot of openly available resources to solve these problems. And this is in stark contrast to high resource languages such as English. And here we can see that for the many tasks of NLP, for English, we have many data sets and multiple models trained on these data sets, and such that we are able to track the progress using a leaderboard. But this is not the case for Southeast Asian languages. So that got us thinking, could we perhaps do something for Southeast Asian languages to close this gap in the resources? So with that in mind, we have the following targets for our project. Firstly, to build open benchmark data sets for ASEAN languages for core NLP. So the idea of core NLP is actually something that we got from the Stanford Core NLP project, and it deals more with foundational tasks such as grammatical analysis and for major languages such as English and French. The reason why we are going with core NLP tasks is because these are generally tasks that are domain agnostic. And what we mean by that is actually that the grammar of a sentence, for example, does not change significantly across domains. So that means that we would be able to have a wider impact by allowing people to benefit from these data sets across multiple use cases. Now, having these data sets will allow us to train models, and we want to help the industry make use of these models more easily. So one thing that we thought of doing would be to showcase them on a demo website, and that will really showcase what's possible and in an easy to understand manner. And we want to have a Python package that provides a simple interface so that the industry can make use of this more easily. And lastly, and perhaps most crucially, we want to establish a regional coalition to promote knowledge and resource sharing, because ASEAN languages are relatively low resource languages, and we're going to need all the help that we can get. So moving on to the proposed solution, I would just like to deal a bit more in detail about each of those aims and what we have done so far. So just to define core NLP a little bit more, we get inspiration from the field of linguistics to look at language on multiple levels of analysis. So at the bottommost level, we are looking at morphological analysis, which is about analyzing language on the level of words. So here we have tasks such as tokenization and part of speech tagging. So from our survey, we find that these tasks are actually quite well taken care of, even if they are not the most accurate at the moment. There are resources out there. However, when we move up one level to syntactic analysis, which is looking at the structure of language, we find that resources are getting more and more scant. And moving up one level higher to semantic analysis, which is looking at the meaning of sentences, we find that there are virtually no resources available for things like co-reference resolution, as well as semantic role labeling. So for the purposes of our project, we define core NLP as all three levels, but we will be focusing on syntactic as well as semantic analysis because of the lack of resources in these areas. And previously, we talked about trying to create a Python package that is easy for use. We have actually produced a beta version of it, and you can download it using pip install. And from the bottom left-hand corner, you can see that it's quite a simple interface to use, and you can do training, evaluation, and inference just using a few lines of code. We also provide a documentation website that goes with this package, and it not only shows people how to use this package, but it also collates information, right? It serves as a sort of one-stop repository for information regarding Southeast Asian NLP. And moving on from here, since we will be publishing datasets for open use, we would also want to include the annotation guidelines for these datasets within this documentation website. And moving on to the regional NLP coalition that we were talking about, we have already established a preliminary network in the region, working with partners in Indonesia, Thailand, the Philippines, Vietnam, Sri Lanka, and India. And we work with them in order to create those data sets that we were talking about in the languages that are available in those countries. And you will realize that these are all universities that we are working with. This is important because we need the right manpower in order to do these projects. So previously I mentioned that we are looking at doing semantic and syntactic analysis for language, right? And this is going to require quite a high level of linguistic knowledge in terms of creating such data. So we find that working with graduates and undergraduates in linguistics is quite good for doing such tasks. And we also work with professors doing research in NLP and linguistics, so that when we adapt existing guidelines to the languages that we are doing, we know that the decisions that we are making are based on sound research as well as linguistically motivated. Moving on to the impact of our data sets. We have benchmark data sets that will help us to evaluate our models more meaningfully. And this will also allow us to have leaderboard competitions, which will help us to catalyze research and development of new language models, as well as novel NLP solutions. And at the same time, having such rich linguistic annotations will help us to promote linguistic research and allow us to probe language models, allowing us to see on what kinds of linguistic phenomena our language models are not performing as well, and then we can further improve on them in that way. And in so doing, we improve the interpretability of such models. At the same time, there's also the impact of the models that we train on such data sets. So we can look at it from a direct usage as well as an indirect usage point of view. One example of a direct usage of these models would be for information extraction. So here we have an example of a news article, and we apply some of these methods to get information out of them. So for example, we can use NER to extract entities from the data set. And we can also use semantic role labeling to find out who did what to whom. So that gives us an idea of the actors that are involved and what kinds of events and actions are happening within the text. And we can go one step further to use co-reference resolution to find out which entities within the text refer to the same real-world entity that will help us to better cluster the information within the text. But we can also use the output from such models in an indirect manner, which is to use them as features for downstream tasks. And this would then allow us to really apply the output across a lot of different use cases. So one of the good examples for this would be machine translation. And a lot of research has shown how we can make use of such semantic and syntactic features to boost the performance of machine translation models downstream. Moving on to the outcomes. We are happy to say that for the data sets that we wanted to create, right now we have already created 3 Indonesian data sets, and they are actually right now the biggest or largest data sets available for each of their respective tasks at the moment. We have also written some research papers regarding these papers, and they are currently under review. So we aim to do the same for other languages, and right now we have datasets for Thai and Tamil undergoing annotation and quality control, and we will be very happy to open them up once we are done with them. And throughout this process of linguistic annotation, we have really found that working together as a region really speeds things up, because despite the fact that all these languages are from diverse language families, research has shown that there are a lot of typological similarities across them. And when we find challenges in one language dealing with a particular linguistic feature, we can learn from that and transfer that to the other languages that we are dealing with. And that allows us to make better decisions and create better quality data sets as we move along. And last of all, we have that image over there, which is the demo that we have already created. It is of course not complete as of yet, but we already support all the tasks that we have mentioned. And we support mainly Indonesian, Thai, and Vietnamese, with certain tasks covering languages like Burmese, Khmer, and Lao as well. So in conclusion, we want to build high-quality benchmark data sets for Southeast Asian languages. We want the industry to be able to use them easily. And we also want to get the region to work together towards this goal. Right, so for future works, we want to scale up our operations to include more languages and tasks, as well as larger data volumes. And we also want to grow the regional network to more countries and organizations. So if anyone here is interested to explore some collaboration opportunities with us, we would definitely be more than happy to have a chat with you as well. So this is the end of my presentation. I just want to give a quick shout out to some of the partners that we work with. We are supposed to have Dr. Ayu with us today, but due to some other commitments, she cannot make it today. Yeah, and we also want to acknowledge Datasoft, who has provided us with the annotation platform for our projects. That's all from me. Thank you very much. And we'll take any questions from now.
Thank you for the interesting presentation. Now, this is the time for question and answer. So please. Yes, I have one question. In doing the benchmark data set, I like to know that do you use the Asian language tree band in your benchmark data set?
Yeah, so right now we are actually creating new data sets, but of course the Asian language tree bank is actually a source of inspiration for us as well. Oh. So actually some of the models that we put onto the demo website as well, they were trained on the Asian language tree bank. So we do have a Burmese constituency parser on our website, for example.
Yeah.
Yeah.
Thank you.
Thank you.
Any more questions?
There were some projects before of IVO on natural language processing. Do you have any document or search on the documentation of the projects before? IVO project?
You mean similar projects done on such language annotation projects?
Yeah. Because of some they had some result before.
Right. Yeah. Yes. So we took whatever we could from what is out there right now. So we consolidated all the resources out there and whatever projects have been done before onto that documentation website that we talked about. So they're all available there. But we are building on top of whatever is already out there. So we try not to overlap with what is already done. There was one, I think U-Star, but that one was a bit more towards speech data. And we kind of ended, I think quite a few years back. So yeah, we try not to do any overlaps with currently available data sets.
Thank you. And any more questions? Okay, now it's time to conclude our session. Thank you for the presentations. Thank you all.